Hello everyone, welcome back. In today's lecture, we are going to learn how to check whether a function is even, odd, or neither. Even and odd functions. Let's begin with the basic idea. Graphically, a function is called even function if its graph is symmetric about y-axis. Symmetry about the y-axis means the left side of the graph is the mirror image of the right side. For example, look at the graph of this function fx equal to x square. Here left side is a mirror image of right side. So function is even function. A function is called odd function if its graph is symmetric about origin. Symmetry about the origin means if we rotate the graph by 180 degree about the origin, the graph looks the same. For example, the graph of the function fx equal to x. Rotate it by 180 degree about the origin, then this graph remains the same. Hence, this is odd function. If in graph of any function there is no symmetry about y-axis and about origin, then that function is called neither even nor odd. Mathematically, a real valued function that is defined on symmetric domain D. Symmetric domain means if x belongs to D, this implies that minus x also belongs to D. So a real valued function defined on symmetric domain D is called even function if f of minus x equal to f of x. It means function has the same value at x and minus x for all domain values. See in the graph of function fx equal to x square. So here the function value at 1, it is 1. Also function value at minus 1, it is also 1. So function has same value at 1 and minus 1. So it is even function. Also, if we replace x by minus x in this function, see f of minus x equal to minus x square, which is equal to x square, means original function we are getting here. So f of minus x equal to f of x. So it is even function. A function is called odd function if f of minus x equal to minus of fx for all domain values. Means function value at minus x is the negative of the function value at x. See the graph of function fx equal to x. Here function value at minus 1, which is minus 1, is the negative of the function value at 1. So function is odd function. If neither of these conditions holds, means function value at minus x is not equal to function value at x, and function value at minus x is not equal to minus of fx, means negative of the function value, then function is called neither even nor odd. Let's identify some functions. First function is f of x equal to mod x, modulus function. First we check mathematically that this function is even or odd. So if we replace x by minus x here, so we are getting mod x means original function. So mathematically this function is even function because value of function at minus x equal to value of function at x. Graphically, see left side of the graph is a mirror image of right side. So graphically also it is even function. Second example is f of x equal to 3, constant function. This function is also even function. Let us check. Replace x by minus x here. Value is 3, which is same as original function. So here also function value at minus x, and it is equal to function value at x. So mathematically it is even function. If we draw the graph of this function, see, left side of the graph is the mirror image of right side with respect to y-axis. So it is even function. Now other function is cosine function, cos x. So mathematically we know that cos of minus x equal to cos x, means function value at x and minus x both are same. So mathematically it is even function. If we draw the graph of this function, see, the graph of cosine function also shows symmetric wave pattern. See, this is the left side and this is right side. So here you see that left side is the mirror image of right side about y-axis. Hence, cos x function is even function. Now we discuss some other examples. Function is x cube. So mathematically we check function is even or odd. So we replace x by minus x here. So we are getting negative of the function. So function value at minus x is the negative of original function value. So this function is odd function. Also, graphically, see, cubic curve is symmetric about the origin. Means if we rotate the graph by 180 degree, there will be no change in graph. Graph will be same. Hence, it is odd function. Sin x. Sine function, as we know that sine of minus x equal to minus of sine x. So function value at minus x is the negative of original function value, hence it is odd function. If we draw the graph of this function, see, the graph is symmetric about origin. Okay, so sin x is odd. Tangent function. We know that the value of tangent function at minus x equal to, we can write sine of minus x divided by cos minus x. Sine minus x is minus sine x. Cos minus x is cos x. So it is minus tan of x. So here tan function, tangent function value at minus x is equal to negative of tan x. So it is odd function. Graphically, this is the graph of tangent function. See, here the graph of tangent function is symmetric about origin. So it is odd function. Now question is, what happens when we add, subtract, multiply or divide even and odd functions? Sum or difference of two even functions is even. For example, x square plus minus x mod x. See, Here x square is even, mod x is also even, so result will be even function. Sum or difference of two functions, one is even and one is odd. It is neither even nor odd. We can consider some examples like if even function is x square and odd function is x. So x square plus x and x square minus x, both functions will be neither even nor odd. Sum or difference of two odd functions is odd. For example, if sin x plus x cube, sin x is odd function, x cube is odd function. So sum sin x plus x cube and difference sin x minus x cube, both will be odd function. Now product rules. Product of two even functions is even. For example, x square into mod x. X square is even function, mod x is even function, but product will be also even function. Product of two functions, one is even, one is odd, product will be odd. For example, cos x into x5. Cos x is even function, x raised to the 5 is odd function, so result will be odd function. Product of two odd functions is even. Okay, so for example, one function is 10x into x cube. So 10 function is odd function, x cube also odd function, but product will be even function. These results can be proved mathematically. Let's take two functions f and g, and first we check f plus g is even, odd, neither even nor odd for all cases. Means here we are going to discuss four cases. So f plus g minus x, we can write f of minus x plus g of minus x. Now four cases arise. First is if both functions are even, then f of minus x will be f of x, g of minus x, g of x. That can be written f plus gx. So if both functions are even, then we are getting original function value, hence f plus g will be even. If any one function, is even and other is odd function, means one is even, one is odd function, in that case function will be neither even nor odd. If both functions are odd, see f of minus x can be written as minus fx and g of minus x will be minus gx. So it will be minus of f plus gx. Okay, so when both functions are odd, f plus g will be odd. Now for product rules. F into g minus x, product of two functions, we find value at minus x, which we can write f of minus x into g of minus x. Now again four cases arise. When both functions are even, then f of minus x will be f of x, g of minus x we can write gx, means fgx. So fg of minus x will be fgx, means product function has same value at x and minus x, so it is even. So product of two even functions is even. Same we can prove for two functions when one is even, one is odd. Okay, so in that case function product function will be odd function. If both functions are odd, then see here f of minus x equal to minus of fx, g of minus x equal to minus gx. That can be written as fgx. Means if both functions are odd, then product will be even function. Okay. Similarly, results can be proved for subtraction and division also, provided that denominator must be non-zero. Example is, check whether the following function is even, odd or neither. Given function is modulus x plus 1 and domain is set of all real numbers. So for the given function, domain is symmetric. As we know x belongs to R, this implies that minus x also belongs to R. Now to check the given function is even, odd or neither, we replace x by minus x and evaluate function value at minus x. So we get modulus minus x plus 1. This can be written as modulus 1 minus x. So modulus 1 minus x is not equal to given function, which is modulus x plus 1. Also, this output modulus 1 minus x is not equal to negative of given function, which is minus modulus x plus 1. Hence we say given function is neither even nor odd. Now we draw the graph of this function. We check for symmetry. So left side of this graph is not the mirror image of right side of the graph with respect to y-axis. Hence, the given function is not even. Now we check for odd function, odd symmetry. So if we rotate this graph by 180-degree, you will see graph will change. So function is not odd also. So finally, using graphical method, we can say that function is neither even nor odd. Now we check the constant function is even, odd or neither. Constant function is defined as f of x equal to c for all x belongs to domain. So to check the constant function is even or odd or neither, we replace x by minus x. So the value of function at minus x is also c, which is equal to value of the function. So here we are getting f of minus x equal to f of x. So function has same value at x and minus x. This implies function is even function for any value of c. Now for checking for odd function, we evaluate both values. Value of function at minus x, that is c. Is this value equal to minus of fx, negative of the function value? So we write c equal to minus c for odd function. This implies that c equal to 0. Means if c is 0, then constant function will be odd function also. So we can conclude if c not equal to 0, then function f of x equal to c, constant function is even only. But if c equal to 0, then constant function is both even and odd. If we draw the graph of constant function fx equal to 2. So here c is 2, which is non-zero. We see that this graph is symmetric about y-axis. Left side is the mirror image of right side. Hence, it is even function. Now, this function is f of x equal to 0, means c equal to 0. So, you can see that left side of this graph is symmetric Left side of this graph is the mirror image of right side. Graph is symmetry. So f of x equal to 0 is even. As we have earlier discussed that f of x equal to c is even function if c not equal to 0. Now we check forward. If we rotate this graph by 180 degree, then graph looks same. Okay. So this function fx equal to c for c equal to 0 is odd also. So graphically also we conclude that if c not equal to 0 then constant function is even only, but if c equal to 0 then function is even and odd both. Function is e raised to the power x plus modulus x cube. To check the symmetry of the function, we replace x by minus x and obtain e raised to the power minus x plus mod minus x cube. As we know mod minus x equal to mod of x, so it is e raised to the power minus x plus mod x cube. This output is not equal to the value of function at x, which is e raised to the power x plus mod x cube. Also, the output value is not equal to the negative of the function value at x, which is minus e raised to the power x plus mod x cube. Hence, the given function is neither even nor odd. Now we discuss some examples of functions that are neither even nor odd. Polynomials with mixed even and odd powers are neither even nor odd. For example, x cube plus x square. Exponential functions. Functions of this form a raised to the power x, where a is not equal to 1 and a is always greater than 0. Exponential function a raised to the power x, neither even nor odd. Now logarithmic functions are also neither even nor odd. Logarithmic functions are the inverse of exponential functions, and we define logarithmic function as y equal to log of x with base a, and a has the same properties that we have defined in exponential function. Shifted functions. Suppose we have a function y equal to mod x. Mod x function is even function, but if this function, the graph of this function is shifted, means if we want to check for mod x plus 1, means the graph of this function is shifted horizontally to the left. So now this function is neither even nor odd. Because shifting properties breaks the symmetry. That's why shifted functions are neither even nor odd. Special notes about even and odd functions. Zero function that is defined as f of x equal to 0 is both even and odd. Any function can be written or decomposed as a sum of its even and odd parts. That is, suppose this is a function f of x. It can be written as f of x plus f of minus x divided by 2 plus f of x minus f of minus x divided by 2. Here, this part is even part and this part is odd part. Now, even and odd functions and their operations are very useful in integration, Fourier series, and symmetric problems. In case of integration, when we integrate a function over symmetric interval minus a to a. Okay, then the integral value will be 0 if function is odd, and this integral value will be twice of integration 0 to a if function is even. Okay, so the even and odd functions are very useful to simplify the expressions, also to reduce the computation part. That's all for today's lecture on even and odd functions. I hope the explanation was clear and helpful. If you found this lecture useful, please like the video, subscribe to the channel, and you can share your thoughts in the comment section also. Thank you.